Hi all, it's another tutorial. This time we're gonna wire up our first CNC. For me it's not the first one, but we will, as a request on the internet, I will do a full request. This here is the standard brick. This here is a TB6600 and it's used to make a stepper motor walking, and we use also the small CNC bob. The brick here is about $8, about $5 you can get interface board. This here is for 5-axis, and I also have here a Meanwell power supply with 24 and 5 volts both together. I set up here a meter, and I also have oscilloscope here to get the things wired. So what do we use on wire? I recommend you, let's go that way, to use a wire set that is plugged in here in those white things. Those are JST XH3S. 3S stands for 3 wires and a supply. We have here a standard PC. This is one of my usually one here. It's a Fujitsu Siemens P5915 or 25. Doesn't matter, both work. They have latency below 10,000 and will work really good. So let's start wiring. As you see here, they're coming out 4 cables of the motor, of the stepper itself. If you have 6 or 8, it's different, but you maybe get a data sheet with your stepper motor how to connect. I wired it here up for a standard one here to a plug. Of course, I want to show you, I'm now going here to 200 ohms on the meter, and let's give me, there are the measurements. Sorry, I only have a hand here to get it inside. I plug it in, there we go. You see here, it's the 2 lines. You can measure about 1.7 ohms. It should be the same on the second one. The motor here is broken. I will show you. There is a lot of more. So I put the second strange and I got 10 ohms. It will work for the test, but in the machine I don't like to do this one. Also, you have a different measurement if you unplug the motor. Here on the brick it's marked here A+, A-, and B+, B-. These are the 4 motor wires that comes through. Only for info, it will work normally. So what I will say is you can measure both lines. They are only between the 2 lines measurements. From one line to this line will now you can't measure anything. If you measure something within 3 wires, it's totally a mess and it's a broken motor. So let's have this one. The second one, as I said, here is 24 volts. This is the red wire, 24, and the ground of 24 volts go into the brick. Here, the input voltage of the brick. Keep in mind there are 40 volts on the brick, but only 36 will do it. If you go to 40 volts, it will break the brick. For more information, at higher voltage, the stepper speeds up more. So there are also on the side here dip switches. You may get a data sheet with your motor, put in the RMS, so the peak voltage is the measurement. Here are the informations, and I recommend you to go to 400 steps per revolution. Set up your hardware to go as precise you want with a 400 revolution on the motor and on the brick. If you go higher, there are up to 24,000 steps per revolution. If you go higher, you will lose torque and lose speed. So let's see. Here there's the thin wires here, the red and the black one are wired up here to the PC ground and PC 5 volt. Here's the ground and here's the 5 volt. There's the oscilloscope is also in here, so you see here 3 wires. I grounded it to have a better measurement. This is all you need for output. All outputs will work. If you will need to work the relay, the analog, there's a PWM to analog, so 0 to 10 volt will run you a VFD, so a spindle, a hyper spindle. And if you need that, or you need the other side, the inputs, you need to get a minimum of 12 volt, a maximum of 24 volts to this port here. It's shown on, there are markings here on the board. It's shown how it functions, and there are a lot of videos of mine you will see. So how is it connected on the brick? The brick here has 3 inputs. It's enable, it's steer and pulse. All plus marked signs here, pulse plus, steer plus and enable plus goes to 5 volt positive. So it's the same 5 volt that goes to the bulb. Just as you see here, I run here from the plugs. Here it runs up there, and it is here bricked from one to the other. So, and also the 3 other plugs here go to the enable pin, goes to port 14, enable minus. Steer pin is shown on the board here. Here are the markings where it goes. It's steer goes to pin 2, I think, and pulse goes to pin pulse goes to pin 2 and steer goes to pin 3. So this is the setup of our system hardware involved here. So once more we'll show you up there, and now we're gonna go to our PC hardware. Let's say hardware is set up, so we go to our PC here. I run VC, I go to CNC and start step conf wizard. It's in German, sorry. And now start a new configuration, create a new configuration and forward. It says the machine name, let's name it test. Don't use spaces, all together and all low cases. I will say test 542. No, I go for TB6600. Yeah, that's it. So here the second one is XYZ, and I'm here on millimeter, and for the first time I leave this one here. It's 5,000, 5,000, 2,000, 20,000, 20,000. So now you need the jitter the problem of your system. I will give it here a 25,000. Of course, I measured it. Everything below 100,000 is good enough to go. If you measure 10,000, go to 20,000. If you measure 30,000, go to 50,000. Always about 20,000 higher. You always can go lower in the next setup. So now forward, and here is the setup of our bob. As you see here, it's a power port address. Where do I get the power port address from? Normally you should know it. I start here a terminal. It's with the mouse. Let's see here, down there is a terminal. Here's the terminal located. You can ask the PC. It's the message. Oh, it's password. What does it say? Why? Let's see if it is there. Problem at all. I did it once before, but now it's not in the... There it is. It's the message, bracket, crep, PA, I would say PA port, PA PO, and the star. And now you're getting informations on the PC itself. Here it says we have 2 PA ports on the system. I know it's the 0. Here it's the real number, not the number within brackets. Sometimes you're gonna show number in brackets here. It's the number before. It's normally 0x378 on a standard US PC. Here it's 0x2008. So let's give it here down there 0x2008. Here you see here. So now set up the system. I don't have for testing here a spindle, a tool inside. So pin 1 is not connected. If you have a VFD, you will go here for PWM mode in this side here. I leave it unconnected. It is right set for this bob. So I have X step, X direction. The other things are right. Pin 14 will activate the brick, activate the, what does it say in English? It's only one activating here. Activate the amplifier. The amplifier is it, yeah. And so pin 16 is not connected, and pin 17 is the relay. I use it here for spindle on, tool on. Here we go. So no inputs. That's it for this side. I did the wrong here. Here you see it should say tool on. Nothing connected here, and go forward. Here I don't recommend anything setting. You will get information what this is in another tutorial. Here we leave it just for this tutorial. So now is the setting of the axis. The motor itself has normally 200 steps. I recommended you to go 400 steps, so 1 micro step. It's 2 here. We have a timing belt system. Normally if you go with 5mm ball screw, you would use a timing belt system with 20 on the motor teeth and 25 here. So you have 5mm pitch. I recommend you here to go for the first time 40 and 120 as the speed. I leave this here. It's the setting of your table white. So as you see here, I'm getting down there. 100 steps per millimeter. That's exactly perfect measurement. I'm in full speed in 0.3 seconds and I need 6 millimeter of white to go full step. If you go here in the real machine, you will go here instead of 120, you will go here 250, and you will see here it drops down to 3 millimeter, so you can pull it up just for testing 120. As I only connected one motor here to the X plug-in, I will not do anything to Y and not to Z. I leave it that way. So I'm done. Save it. Yes, there we are. So now we start up our machine. It's also measured here. CNC and Linux CNC. So now you will see under my configuration, you will see the machine. I now need to look where it is. There it is. Belong here. And inside the folder, there's the real machine. Here, this is the machine you need to start. Where is it? Here. There are we going. This is the machine we need to start. Now it should start up. There's our system. Here you see I go over. I have now I need a wide view. Here you see the maximum measurement. We talked about 2400 millimeter. So then now we power up our system. I hit the plug and we see here the green light for power. Here's also the green light. So now what we're gonna do is first hit F1 on that's the key. F1 or with the mouse over the E-stop. This is now, and the second one is our pin number 14. And now you should hear the motor, and it is stiff now. Yeah, it has power. You also can see it here on the green lights. And if we now hit here left right with the arrow key, the motor should move. You see, within 5 minutes you are done with setting up the system. So what if it fails? You can also measure the bob itself. The newer bobs need maybe direct 12 volt here. I have a lot of from the old one. It's the green one with the one relay. You go here and say it's 20 volt. Let's measure 20 volt. I need to take the cables here. There we go. Sorry for the wild thing. Here you have the cables. There we go. Here. So I go with PC ground and pin number 3. Here you should see 5 volt. Now I hit the arrow key, and now it changes to 0.25 volts. So it goes up and down. You see, something happens. I recommend measuring with the meter only the direction pin. If you need to get signal from the pulse pin, here, this is pin number 2. So let's see if we can get something. Oh, this will be now with the fingers. Let's run it this way. You should see the signal. signal appears. Where we go? There. There's a signal. So we have full action, and we got a running machine within 20 minutes here. I hope you can get it. Hope it next time. So to close it down, you need to hit F2. Now the motor has no power. Here you see I can move it if I hit F2 again. Here the motor is stiff. There's no action. There's full force on it. To get full force, you always need to go for 400. You have it's a potential of the mass. If you go higher, 800 or 1600 or more. So I hope I could help you. Where to ask if something fails? You need to go to our online help channel, Linux CNC. It's on the IRC Internet Relay Chat. There are always, let's say, 150 people there that can help you in all languages. And you see, there's nothing to harm. We will help you. Just log in and see other video of my channel. See you next time. Bye, folks.